Hello everyone. I am walking with GoPro 9 while keeping a walking log, and sometimes upload some of my favorite sceneries on YouTube. On this video, I am going to share how to make a motion animation of the camera shake of the GoPro. The current video you are watching is the very output I am going to create here. This is the outline of this video. First, I am talking about how this video was made. Next, I am explaining how to extract metadata from GoPro video file, MP4 and the contents of the extracted CSV file. Then, I am going to introduce how to get the CAD data, STL file of GoPro used in animation, and then how to simplify STL files using a free software. Finally, let's create an animation using Python, which is one of the most popular programming languages. The GoPro hangs on the neck mount, so I can walk with both hands free. The camera shake is inevitably larger than the hand holding, but because of GoPro's excellent camera shake prevention and horizontal level function, GoPro provides good video quality even in the 5x time warp mode. By the way, I bought a CPL filter a few months ago in order to get vivid color of the blue sky. As you know, CPL filter reduces the reflection light and reveal the real color of the subject. The GoPro in this picture is equipped with a CPL filter. It's 2-in-1, type with a ND8 filter. This current video is also taken in 5x time warp mode with the CPL filter attached. In my previous YouTube video, I compared with and without the CPL filter. The difference between those is very clear. By the way, can you see the color of the blue sky slightly flickering? The reason for this phenomenon is that the GoPro's body, or to be exact, the attached CPL filter, vibrates and rotates around the axis with respect to the direction of the subject, in this case, the blue sky. It's the same reasoning that if you want to get the same effect in vertical and horizontal composition with a camera with a CPL filter, you have to rotate the polarization axis 90 degrees. As I said earlier, GoPro has strong electronic image stabilization and horizontal leveling features, so I didn't realize it at the beginning. The GoPro video file formats contain metadata including the motion information of the GoPro body, so I came up with creating a motion animation, and synchronizing it with the original video. Metadata is extracted at a site called Telemetry Extractor for GoPro. Click Free and drag and drop the MP4 file onto the Choose file. Loading has completed. GoPro 9 metadata contains a lot of information, including GPS information such as latitude, longitude, altitude, and speed, motion information such as acceleration, gyro sensor or angular velocity, and photograph conditions such as shutter speed, ISO sensitivity, and white balance. Here, I use image orientation. Select image orientation, select frame rate at the frequency of the option, and finally, click the CSV format. Let's take a look at the contents of the downloaded CSV file. CTS in column A are internal counts, column B is date and time, columns C to F are quaternions. The quaternion is unfamiliar, difficult mathematics, But here, all you need to know is that it's a mathematical expression showing the direction and rotation of an object. The date and time are recorded in universal time, but not used here. Since I selected the frame rate when extracting before, one line of the CSV file corresponds to one video frame. CAD data for GoPro Hero 9 Black is available online for free if you register an account on the site called GrabCAD. You can download for free. On the library page, type GoPro 9 to search. Use a software called MeshLab to simplify your STL files. Since the font of the menu is small, I added text only to the necessary parts. Read the STL file you got earlier, and then simplify it. Here, for example, let me input 0.1 in the percentage reduction box. As a result of the simplification, we were able to reduce the vertices from 16,068 to 1464. Save with a different file name. Finally, using a programming language called Python, I am going to create an animation. You can also set up the programming environment for free. Even if you are not familiar with Python, there are many articles and videos for beginners on the net and YouTube, so please refer to them. I'm also a Python beginner, because it's been about a month since I started learning Python. I don't have any ability or knowledge to do Python tutorials. Some Python experts may point out my wrong term usage, but let me say please be easy in advance. I'm using Python in the Visual Studio Code you see. I also write the code in the summary column below. Now let me explain the contents of the code. Python has a lot of libraries. This may be one of the reasons why it's now so popular programming languages. Here you need to pre-install the 5 libraries commented by Hash. Once installed, no installation is required, so comment out with Hash. Pandas is a typical library for data analysis, and is used here to read CSV files. PyVista is used when working with 3D models. Here, it's used for reading STL files and drawing 3D models. NumPy and NumPy Quaternion are used for matrix operations and quaternion calculations. ImageIOFF-MPEG is a library for saving videos in MP4 file format. At first, make each library available in the import statements. Next, read a CSV file. And then, make 4 quaternion elements, Q0, Q1, Q2, and Q3 to specify the column name on the first line of the CSV file. Use the plotter method to set the video save settings. Specify the file name to save and set the frame rate to 30. The default frame rate is 24. The default output image size is 1024 by 768. Here I am keeping the default. I specified the background color as blue. Read STL file to create 2 instances, GoPro and GoPro I. These instances consist of the vertex coordinates of the GoPro body and the combination information of the 3 vertices that make up the surfaces. Extract the vertex coordinate information with the method called points. Of the 2 created instances, points I is the initial value, and points are the vertex coordinates that change from frame to frame due to rotation. Generate a quaternion, QUAT, for each line of the CSV file, that is, for each frame of the video. Use for loop statement with the variable I corresponding to the CSV line. Since I selected image orientation, not camera orientation in the metadata extraction said earlier, the signs of Q1, Q2, and Q3 in the imaginary part of the quaternion are inverted in order to perform mirror image transformation. Q1 and Q3 are swapped to match the actual GoPro rotation axis. Quaternion as rotation matrix is a function of the NumPy quaternion library that transforms quaternions into rotation matrices. Using this rotation matrix, the initial values of the vertices, points I, that make up the GoPro body, are rotated and converted to points. Use for loop statement with j as a variable and execute the rotation for all the vertex coordinates that make up the GoPro body. np. Represents the product of vertex coordinates and rotation matrix. Now let's start this code. I skipped on the way. It took 108 seconds on my PC. Let me show the original video with the synchronously created animation. This original video was taken in real speed mode. Here, I was tilting the GoPro several times by hand. You can see that while image stabilization and horizontal maintenance are working very well, the blue color of the sky changes in conjunction with the tilt. Thank you for watching.